Well, thank you, as Sean and Guy said. Thanks everyone for joining, and just really to reiterate what Guy had said regarding this session and sessions that that we'll be running moving forward. Guy and myself, we had a call with Claude and Fabrizia maybe 2 or 3 weeks ago, just conversationally talking about one or two things, and the cloud in quotes kind of cropped up as a topic of some interest in terms of I think particularly in their region, IBM and IBM Cloud being pushed, or being something that was of interest, and something that was on the lips of a lot of customers and prospects. So we kind of sort of agreed that maybe a good place to start this session, if you will, session one of however many, will be to kind of take a step back and talk about cloud computing, the different types of models, the different types of services, and really to provide some context for PKWARE and where PKWARE can play in quote unquote the cloud. Okay, because it's not just as simple as going, it's cloud computing, do you run there, yes or no? There are some sort of subtle nuances that we'll talk about as we go through the slides, and hopefully this is, as I say, this isn't the definitive article. This is a start point. There'll be follow-up questions, there'll be follow-up sessions about this and about many other things, I hope, moving forward. So if any of this is redundant, I do apologize, but I kind of thought it best to level set at so what's cloud computing, and rather than assume that people know, the different service models and the different services that are available. So if some of this is already, yeah, I get this, I know this, I apologize in advance, but I felt it better to start, at the ground, work up, and then when we get to the PKWARE piece, hopefully this all starts to make a little bit more sense about where PKWARE can play, and so on and so forth. Feel free to ask questions as we go along if you wish, or save them to the end. I'm hopeful that we'll get through this in a reasonable amount of time to leave some time at the end for questions, and maybe even suggestions for what you'd like to see next. But that's more Guy and Sean's ownership. I'm merely the receptacle, as it were. That's probably not the right word. I'm delivering this, so okay. Let's move on. So we're going to start, as we said, with what is cloud computing. We'll talk about some of the types of cloud, some of the services, some of the typical use cases for why people are moving to or have moved to the cloud. We'll take a look at security, because I think you'll all agree this is sort of naturally where a lot of people have some reticence about cloud computing, or some concerns about, is it safe? What do I own the data? Do I not? And so on and so forth. And then with that, we'll take a look at where does PKWARE fit in terms of cloud computing. This may change as we move forward. Who knows what's coming along in the product? But as of today, we'll be able to talk a little bit about where the PKWARE solutions fit within the cloud computing world, for want of a better phrase. So, what is cloud computing? I mean, I guess very simply put, cloud computing is the delivery of computing services. So things like servers, storage, databases, software, analytics, whatever it might be, over the internet, or the cloud, if you will. And typically, it offers faster innovation, flexible resources and economies of scale for organizations. And typically, as a user of the cloud, you'll only pay for the cloud services that you use, which helps, obviously, lower operating costs. You can run your infrastructure more efficiently. And I guess more importantly, these days, you can scale as the business needs change. It's very kind of elastic in terms of being able to scale up or scale down. So there's, in general, three different types of cloud computing or models, and I'm sure you're all familiar with these terms. So public cloud are clouds that are owned and operated by third-party cloud providers who deliver their computing resources, like servers and storage, over the internet. And I guess generally, public cloud are characterized as being multi-tenant. They're share everything computing services, and they're pretty elastic. You know, you can scale up, you can scale down very, very quickly. So this is where Microsoft Azure, Amazon AWS, IBM Cloud are examples of that. So with a public cloud, all hardware, software, and the infrastructure that supports that are owned and managed by the cloud provider. So you as a user access those services and you manage your account, typically using a web browser. And in fact, we at PKWARE, we have a very, very big development system and QA system and demo system that we host ourselves on Amazon AWS. And we have a couple of guys back in the office who are responsible for looking after all that. And they can build demo environments in minutes, literally in minutes. They can tear them down in minutes, and we're able to provide that kind of scalability really, really quickly. So it's something that we use internally for our own purposes. However, I mean, having said that, not all workloads, especially enterprise workloads, are suitable to run on public cloud. I mean, there's certainly issues around security, as you would imagine, data egress, performance, and so on and so forth. So if you move over to the other side of the screen, we've got private cloud. And a private cloud refers to cloud computing resources that are used exclusively by a single business or a single organization. A private cloud can be physically located on site in a company's data center, but also some companies pay third-party service providers to host their private cloud as well. That's certainly not unusual. So a private cloud is one where the services and the infrastructure are maintained on a private network. And the private cloud can be as simple as just deploying storage and network and compute within the data center, and building services similar to a public cloud around it. I mean, that's one way of doing it. But a lot of enterprise customers, certainly those with deep pockets, because this isn't cheap, who have requirements for high performance and security and so on, do roll out their own private clouds themselves. In the middle, we've got the hybrid cloud model. And as the name suggests, hybrid clouds combine public and private clouds, and they're bound together by technology that allows data and applications to be shared between them. So by allowing those applications and the data to move between public and private, a hybrid cloud gives the business greater flexibility. You've got more deployment options, and you can kind of, in some instances, maximize your existing infrastructure, your own security, and any compliance initiatives that you may need to adhere to. So, I mean, certainly in my experience, hybrid clouds have gained more popularity in recent times, and we've certainly seen enterprises looking to take advantage of this this kind of model, if you like, for various reasons. I mean, an example might be deploying high-end storage systems on premise and then using the cloud to store backups or archives, or even using the cloud as a replication target. That's quite a popular configuration as well. So you've got replication almost instantaneously, but up to the cloud, is one reason why that might be of interest. So for all of those models, you've got cloud services that can be made available on them. And most computing services fall into these four kind of fairly broad categories. You've got infrastructure as a service, you've got platform as a service, you've got software as a service, and you've got serverless as well. And you may hear, or you may well have heard, these services referred to as the cloud computing stack is kind of typically how they're referred to. So if we take a little a look at each one of these in a little bit more detail, just for for some context, we've got really on the right hand side here infrastructure as a service, and is more of a computing infrastructure that's provisioned and managed over the internet, as we said previously. IaaS quickly scales up and can scale down with demand, and it allows the organization that's paying for this to pay only for what they use. So as we mentioned, it helps avoid expense and complexity of buying physical servers, managing physical servers, power to the data center and resources and all that kind of good stuff that typically you would need to take care of yourself. So each resource is offered as a separate service component, and you only rent what you need for as long as you need it. So the cloud service provider manages the infrastructure, the enterprise purchases, installs, and configures their own software, their own operating systems, their own middleware, their own applications. So you're kind of renting, if you will, bare metal, nothing else. So if we move along to the right, to the left, sorry, a little bit further, we now kind of cover off platform as a service. So platform as a service is a complete deployment and development environment in the cloud with resources that the enterprise can deliver. They can deliver cloud-based apps, they can deliver enterprise applications and so on. But as before, the organization purchases and rents the resources that they need on a pay-as-you-go basis, and then they access them over the internet. But like infrastructure as a service, platform as a service includes storage, servers, networking, but also middleware, development tools, maybe BI, databases, that kind of thing. So it's kind of the next tranche of not just bare metal, but it's the operating systems, it's the servers, it's the stuff that would then sit on top of that infrastructure. Okay. Platform as a service, again, avoids expense and complexity of, I guess, for the user buying software licenses, managing software licenses. They don't need to worry about the application infrastructure. They don't need to worry about orchestration containers or development tools and that kind of thing. The enterprise manages the applications and the services that they develop, and the cloud provider manages everything else. Okay, so we're kind of moving up the stack, if you will, in terms of what's being provided and what's down to the user, if you will, the enterprise. So if we complete this picture, we end up with software as a service, and I think possibly this is the one that people are most familiar with when we talk about software as a service. Software as a service allows users to connect and use cloud-based apps over the internet. So Office 365, Salesforce, Microsoft Dynamics, that kind of thing, stuff where you buy a license and you get a login, and you log in and away you go. You need to put your own data into Salesforce and so on, obviously, but you're kind of renting the application. So SaaS provides the complete software solution, and it's a subscription-based model. And I'm sure we're all familiar with Office 365 or Salesforce or whatever it might be, from that world. In these cases, all of the underlying infrastructure, the middleware, the software, the application data itself, everything's located at the service provider's data center. They manage the hardware, they manage the software. You have a service agreement with them, the details, uptime, downtime, so on and so forth. Availability and security of your data, in quotes. And really, SaaS allows an organization to get up and running quickly with an app at kind of pretty minimal upfront cost. Okay. The last one is serverless. So I'm not so familiar with this. I've not heard this myself that many times, but serverless computing really enables developers to build applications faster by removing the need for them to manage any infrastructure at all. The cloud provider automatically provisions and scales the infrastructure that's needed to run the code, and allows the developers to focus on the business logic of whatever the application is they're developing, and enabling them to deliver more value. It's all about productivity and getting products to market faster, optimizing resources, and staying focused, I guess, on the innovation aspect of the software that they're developing, rather than worrying too much about actually worrying about the infrastructure itself. I mean, I guess it's important to mention that servers are still running the code. They're not actually serverless. The name comes from the fact that this provisioning and management are invisible to the end user, so that's why it's called serverless. Now, apologies to Fabrizia and Claude, especially, for using pizza in this example, but it seemed an apt one to try and show the difference between the different types of model that we've just seen. So, if on the left-hand side here, the traditional on-premise model of a data center or making pizza, you make it at home, you have everything. You as the owner, you've got a dining table, you supply the drinks, you supply the oven, the gas, the fire, the dough, and so on and so forth. And as we move to the right, you'll see that what you manage is the user, the end user, and what the vendor or the cloud provider manages changes over time. So by the time you get to software as a service, effectively it's going out to a restaurant, because you do nothing other than turn up, sit down, and eat your food. Okay, so that was just a way of trying to make this a little bit clearer in terms of what is managed by the enterprise and what's managed by the cloud service provider throughout these different models. If we go on to talk a little bit about the uses of cloud, I mean, everyone's probably using cloud computing right now, even if they don't realize it. If you're using, you're sending emails with Office, or you're editing documents, or you're watching Netflix or Amazon Prime, whatever it might be. Cloud computing is making all of that possible anyway, so it's not new per se, but some of the uses that you're seeing are delivering software on demand, as we've already mentioned. So software as a service is a very, very popular use case. Storing, backing up, and recovering data is a way of being very cost efficient and scaling, or being able to scale that hugely by transferring your data off-site, to a cloud storage system that you can access from anywhere and from any device. So, things like Dropbox for Business is a good example of that, or Crash Plan you might have heard of, or Carbonite Safe. These types of cloud off-prem storage solutions. That's another use case. Collaboration, I guess, that's your Microsoft OneDrive, Dropbox, Google Drive, file sync and share type of use cases and applications. Audio and video, again, self-explanatory. We've mentioned, Spotify, Netflix, Amazon Prime, that kind of thing. Creating cloud native applications is something that's becoming a little more popular as well. So organizations that are looking to build and deploy and scale web apps and mobile apps really quickly, or maybe APIs, using typically cloud native technologies. So, DevOps, flavor of the month at the moment, DevOps, Kubernetes, if you're wanting to automate deployment and scaling of containerized apps, that type of thing. And then again, becoming probably a little more popular is data analysis. So, whether that's using things like Google AI or Azure AI to look at data and try and uncover insight into that data for, more informed business decisions. So kind of machine learning, if you like, artificial intelligence. That's the type of use cases that people would tend to be deploying or would tend to be using for cloud deployment. So a little bit more about security. I mean, data security has become synonymous with cloud security, I would suggest. I mean, more than 90% of companies have adapted cloud services to some degree or another, according to some projections. I'm not saying that that's exactly true. And a lot of IT workloads are being handled in the cloud. So protecting data these days does kind of start to require a cloud-first mentality. The need to exploit the capabilities of the cloud whilst keeping data safe is something that you as security professionals and industry analysts and cloud providers themselves actually have been trying to answer, which is how should data be encrypted in the cloud and who should hold the key? That's kind of the $1 million question, if you will. Most cloud providers offer some form of encryption for their customers' data. Absolutely, they do. Protecting data in transit is fairly simple. I mean, information is almost always encrypted as it travels between data centers or between devices or between servers using TLS or something like that. But protection becomes a lot more complicated for data at rest or data in use when it's in the cloud. Cloud providers can encrypt data on their servers, obviously, but in order to facilitate, online viewing and online collaboration and indexing and all that kind of good stuff, the cloud providers need to maintain control over the keys that are used to encrypt and decrypt the data, because if they don't, you can't get any of that good stuff. So when cloud providers do hold the encryption key or keys, data is at risk from an additional set of threats. So as a user, you not only need to worry about malicious insiders and outsiders who might target your systems, but you also need to be concerned about attacks on the cloud provider themselves. So it's like a double whammy. And since you can't directly control how the cloud providers protect the data or the keys, a lot of organizations are unwilling to accept cloud-based encryption, for really sensitive data. And that's kind of that's the dilemma. But it doesn't end there. Cloud services are further complicated by the issue of data sovereignty, excuse me. The question really of which country's laws apply to the data stored or processed by an organization. So a cloud service provider based in one country that operates data centers in other countries and collects data on residents of other countries, may find itself subject to multiple data protection regulations. And I know in Europe, that's maybe slightly less of an issue with GDPR, which is meant to be a little bit more of a blanket set of compliance regulations. But still, some of these regulations and compliance issues between countries can overlap and in some ways can even contradict. So with these obvious challenges, this data sovereignty does pose a security risk, particularly government seizure of sensitive data. And this we'll talk more about this in a moment. Even if an organization feels confident that its own government won't try and steal its data, it's got to worry now about another government that potentially has jurisdiction, not over its data, but over its cloud provider. And this is where access to encryption keys becomes really, really important. A good example of this, and actually a real life example of this, is the US Cloud Act. So the US Cloud Act gives the US government, under subpoena, the ability to request from a US company access to its data. So if you think about Microsoft and Microsoft Azure, if the US government were to subpoena Microsoft, they could, in theory, ask Microsoft for every piece of data that Microsoft holds in the cloud. Now, some of that's Microsoft's data, some of that is not Microsoft's data, it's Microsoft's customers' data. So we have a customer in Europe, and it is a genuine customer. I can't mention the name because we're not allowed to. They're a global auditing and consultancy company. And last year they signed a 5-year deal with Microsoft to utilize Office 365 and Microsoft Azure. And the idea is that they start to migrate a lot of their on-prem applications into the cloud for the reasons that we spoke about, scalability, cost, performance, and so on and so forth. But they use, among the applications they're migrating, they use 2 auditing applications globally to assist with gathering information for their clients, auditing their clients, sending data back to their clients, and so on and so forth. So they're hosting this in Azure, and in Europe they faced a legal challenge, which meant that under the US Cloud Act, their European customer data was subject to being exposed to the US government under subpoena. If Microsoft was subpoenaed, they have to give access to this data to the US government. So they looked at a number of ways to protect that data, Microsoft Azure being one of them. Obviously, there's a bit of a conflict of interest there. And in fact, what they ended up doing was investing in SmartCrypt, PKWARE SmartCrypt transparent data encryption to encrypt data in the cloud, whilst they maintained control of the encryption keys. So if Microsoft was subpoenaed by the US government, federal government, all that Microsoft would be able to offer them from this client's customers' data would be encrypted data. So that's an example of data sovereignty. That's an example of where some of the challenges are in terms of protecting data. It's not only about protecting your data from inside a threat. It's about protecting it potentially from other governments that may have a legal right to access that data through something like the US Cloud Act. And that's not the only one, but that's the one that was relevant for our customers very recently. So companies using cloud services generally have 3 options for encryption and for key management. There's cloud-based encryption, which, as we've mentioned, the cloud provider generates and manages and stores the keys, and they encrypt and decrypt the data. Fine. There's bring your own key, BYOK. The customer generates and manages the encryption keys, but the cloud provider has access to the keys and can use them to encrypt and decrypt. Or there's hold your own key, HYOK. The customer generates and manages and stores encryption keys in its own environment. The cloud provider does not have access to the keys and is blind to the contents of the encrypted files, which may be a preferable situation. And certainly that was the situation that we had with our customer in Europe that we just spoke about. So some organizations' security policies are going to dictate that they hold your own key to all sensitive data. And for these companies, the cloud really becomes like a storage location, if you like. Sensitive data resides on the servers, but it's only decrypted and used inside the company network or by external partners under very controlled circumstances. But most organizations need to take place of additional cloud capabilities such as collaboration, cloud DLP scanning, online searching, and so on for at least some of the sensitive data. In these cases, hold your own key can be implemented side by side with cloud security. Data that an organization considers appropriate for cloud-based use can be encrypted with keys that the cloud provider holds. But data that requires maximum protection can be encrypted with company-held keys, meaning that they can't be accessed by the cloud provider. The cloud provider is still able to do housekeeping, like backing up and all that kind of good stuff, but there becomes a separation of duties between the administrators from the cloud provider and access to the sensitive data. They become 2 completely separate things. So from a security perspective, PKWARE, as you know, enables policy-based data protection. And this can happen in the cloud, you know, and it gives the organizations the ability to maintain control over sensitive data, you know, no matter where it is and where it travels, and so on. But with some of the other capabilities around discovery and classification, it allows administrators, you know, that visibility and flexibility to keep data safe from unauthorized use, even outside of the network now. The agents, you know, PKWARE agents, when they're installed, can protect data by remediating it, you know, in a number of ways. And, you know, it can be encrypted, it can be quarantined, it can be deleted, and under certain circumstances, it can be masked as well. So there's a number of ways that PKWARE can help customers there in the cloud by allowing them to kind of grant access and revoke access to encrypted data quickly and easily, by, you know, simply by adding and removing users from a smart keys access control list. We won't go too much into smart crypts at this point, because that's possibly another another session. But coming on to where can it be installed? I mean, if data isn't properly protected, then loss and, you know, data loss, data exposure can happen in the cloud, whether it's any of these, whether it's on-prem, whether it's public, whether it's hybrid. For on-prem and private cloud, especially, many organizations think that they are more secure than public ones because the data remains within the company's existing infrastructure. But in this scenario, the same risks that existed in the physical data center still hold true. You know, you've got trusted insiders historically, you know, that have access to systems. They can look at data, they can steal it if it's not protected. And the great example that we've always used there is our good friend Edward Snowden, who, you know, was the guy that worked for the NSA, who leaked, you know, gigabytes of confidential information. But Edward Snowden was actually a SharePoint administrator at the NSA. He wasn't a spy. He wasn't, you know, anything other than a guy that administered SharePoint, that had access through access control to that information. You know, he could steal it. He was able to leak it. So, you know, insider threats aren't new, but certainly as data centers start to go virtual, and you know, with the cloud, traditional access mechanisms do become less effective if the controls aren't ported, you know, into the virtual realm. So the need for encryption again becomes ever more important. Just trying to think. I mean, if you're leveraging a public cloud, or if organizations are leveraging a public cloud, they can take advantage of the cloud providers, you know, infrastructure as a platform, or, you know, infrastructure as a service, platform as a service, or software as a service. Data stored outside of the data centers in the cloud provider's environment, and this could mean, you know, this could mean separation between customers with different virtual machines on the same physical device, different logins to the same service or same applications such as Salesforce. So, you know, insider threats still exist in the public cloud as well. Some companies may feel safer with the hybrid approach because that combines both the public and private cloud. And then some data, I guess often the stuff that's classified as highly sensitive stays with the organization in the private cloud, and the other data can be stored in the public cloud. Another hybrid option is where a customer contracts for physically separate servers and applications within the cloud services, the cloud provider's infrastructure. I mean, certainly that model provides more security than a standard public cloud, but obviously there's additional concerns there around cost and so on and so forth. So where can PKWARE be installed in the cloud? For clients that are moving completely to software as a service, there's no real play for PKWARE security or compression. technology, really. If you think about Salesforce, if you think about Microsoft Dynamics, they're kind of turnkey black box applications that don't really allow for any entry point, for additional software, additional encryption software, compression software to be deployed. I mean, if there was any compression, it would probably take place on the service provider's side of things, compressing the data there. And any encryption of data in transit is going to be, through TLS. If data-centric encryption is required, actually encrypting the data itself and decrypting the data itself, more likely a customer is going to look to implement a cloud security access broker, or CASB for short. So that's, if you know, I apologize, but a CASB is an on-prem or cloud-based security policy point, if you will, that's placed between the cloud service consumer and the cloud service provider to combine security policies as cloud-based resources are accessed. So from an encryption and decryption angle, at a very high level, it decrypts data coming from the cloud app, such as SFDC or Office 365, and it presents that data in clear text to the end user in the web browser, and then encrypts that data when it's sent back to the cloud. That said, customers that are using Office 365 with laptop client software, and there's many of those still. Not everyone's gone pure Office 365 and no client footprint. So for those that still have client software, Office software installed, they can still make use of PKWARE solutions as we know and love today. So you can still install PKZip, you can still install SmartCrypt, SecureZip, whatever it might be, to compress, decompress, encrypt, decrypt data as it enters and leaves the cloud. And a typical use case for that, and one that we see a hell of a lot, particularly with the uptake of Office 365, is encryption of data before it's synchronized to the cloud using like OneDrive for Business. So you have a business subscription of Office 365, you get OneDrive for Business. So great collaboration tool. You can roll it out to all the end users, and you can all collaborate quite happily. But therein still lies the challenge of making sure any sensitive data that is used for collaboration is secure before it leaves the network perimeter and goes to, the cloud. And that's one that we see more and more, is people wanting to make use of Office 365 capability, but have a concern around, is that data to be, how do we secure that data before it's synchronized and used for collaboration between teams that aren't, they're not necessarily in the same office in the same country, they're geographically spread. I mean, that the same applies to Dropbox as well, and Google OneDrive, and other file sync and share solutions are available. So one, I guess, concerning downside is the loss of control over some or all of the cloud environment that house the data. So infrastructure as a service, platform as a service, they all impact data control and governance differently. With infrastructure as a service, the customer may have full control over the server configuration, allowing them more control over the environment and the data. Platform as a service, the provider manages all of that, which limits the risk management capabilities. And with software as a service, both platform and infrastructure are fully managed, which means if the underlying operating system isn't configured properly, the data in the higher layer application could be at risk as well. So all of these considerations have implications for compliance and accountability. The remit for data protection usually goes back to the original steward, the entity that created or requested the data in the first place. If you think about a large bank, if a customer provides personal information to the bank, they expect that bank to protect it. It doesn't matter to the customer or to the auditors or to the media that the bank entrusted their data to a cloud provider. All that matters is whether or not the data goes missing in the first place. For both infrastructure as a service and platform as a service, the organization has much greater access and control to the resources available from the cloud provider. And typically they can and do install additional software on these resources. In these instances, PKWARE products can be deployed exactly as if they were on-prem by the end user. There's no difference. The US Cloud Act example that we spoke about earlier was deployed on, and I can't remember exactly whether it was platform as a service or infrastructure as a service, but it was deployed by the end user on Microsoft Azure to fix exactly this issue. You know, and if you think about the old outsourcing model, if you like, where, you know, IBM, for example, would, you know, they run a customer's mainframe workload on their own physical machine. That customer could, and still do, you know, they still run PKZip, they still run SecureZip, they still run PKWARE products, even though it's outsourced by IBM. So that cloud model really isn't that much different. It's just somebody else running the information, running the applications, but you've got access to install and configure whatever you need to augment, you know, your applications and the infrastructure that you're renting. So, I mean, the slide everyone's waiting for, summary. I mean, there's no doubt that the cloud brings a lot of advantages to enterprises today, and that's, you know, that's why, you know, there's this big push by IBM in Italy at the moment, and, you know, we're seeing it over in the UK, you know, with Amazon and Microsoft. You know, they're pushing the hell out of Azure over in the UK currently. You know, there's cost savings, 24/7 access, high availability. But both public and private cloud introduce a layer of abstraction between the original owner of the data and the ongoing stewardship of that data, especially in the public cloud, where providers manage both the cloud infrastructure and the personnel, you know, the resources that run it. So one way to ensure that data in the cloud is protected is looking to choose a solution that encrypts the data before it leaves the trusted zone, if you will. Ideally at the file level, because that's the data centric posture that we all love and you know and is being embraced, I think, a lot more now in the world. IT administrators and end users can take back some control over their data protection by using that data centric approach. You know, it's portable across all platforms, it's portable across all the operating systems, and it works within pretty much any computing environment. So it kind of negates, it doesn't matter where the data is and what operating system you're running it on, you know, you can be covered there. I mean, and if it's used properly, you know, it does prevent this unauthorized access, unauthorized tampering, separation of duties with the cloud provider's personnel, regardless of, you know, how the data travels and what it does. And it just means that organizations can enjoy, you know, the benefits of this cloud computing without putting their sensitive data at risk. That was all I had for the moment. I appreciate that it's perhaps a little bit of duplication from what you may know already, but I felt it was important, as I said at the beginning, to provide some context and some information about, you know, the different types of cloud model, the different types of services, because it's not just as simple as saying we can run in the cloud or we cannot run in the cloud. Like every good pre-sales consultant globally, the answer is it depends. And as you've seen, it depends. Depends what the customer wants to do. It depends what model they're looking to take. It depends what services they're thinking of using. There are going to be some instances where there isn't a play today for PKWARE. That's more typically software as a service. We don't have a CASB, so we're very, very limited as to what we can provide there. Anytime the customer is looking to go infrastructure as a service or platform as a service, there's more control, that the organization has over the infrastructure, the storage, the network, the servers. And in those circumstances, the conversation can be as if they were looking to deploy on-prem, exactly the same. Okay.